Today we're reviewing for your benchmark, which starts on Monday. Today we're going to look at some free body diagrams, in other words, calculating net forces. We're going to be calculating some speed problems using word problems and maps. All right, so everybody should have their science spiral out. And let's go ahead and draw this picture. This is what's called a free body diagram. And again, when you draw the picture, you do not need to draw it exactly as you see it. For example, the skydiver, you can just draw him as a circle. Okay, so let's go ahead and draw this guy. And he has, so instead of drawing a skydiver, just draw a circle for the skydiver and draw these arrows and label the forces. So he has two forces acting on him. And the first force is pulling down on him. Very good. And that would be, yes, the force of little g, which is the force of gravity. So yes, the force of gravity is pulling down on him. Does anybody know what force is opposing his motion?
Wind.
Okay, wind what?
Wind friction.
Very good. Okay. So what is opposing his motion is the force of friction, in this case, air friction. Okay. So next thing you need to ask yourself, so you should draw the skydiver with these arrows and label it 50 newtons and 40 newtons. Next thing you need to ask yourself is, are these adding forces or opposing forces? These are opposing, okay? Jaime, were you able to get in? To just try to get into Zoom. If you can get in Zoom, good enough. In fact, I can email you the link. So, give me 1 second. I have people emailing me about the School of G. All right. Oops. All right. So I just emailed you the link, Jaime. Oops. Get out of my way. There goes that. All right. So, who that was? Somebody. I'm sorry. All right. So getting back to it. Yes. Yes. All right. So because these are opposing forces, we're going to subtract. So 50 minus 40 is 10 newtons. Okay, 10 newtons. You always go with the biggest number, and the biggest number is 50. So that's going to be 10 newtons going downwards. This is our net force. Another way of thinking about net force is the answer. Our answer is 10 newtons. Okay, the net force would be the sum. How many are you trying to get in? All right, so next question, is this balanced or unbalanced? Delilah? If its net force is 10 newtons going down, is that balanced or unbalanced? So the rule is anytime it's not zero, it's unbalanced. So 0 newtons is balanced. If it's not 0 newtons, if it's anything other than 0, it's unbalanced. All right, so this is going to be unbalanced because it's not 0. And what's going to happen? He's going to accelerate downwards. Okay? So, again, what you do is you calculate. You look at them, and I say, okay, they're going in opposite directions, so they're opposing, so I'm going to subtract. You calculate the net force, which is 10 newtons, and then if it's not 0 newtons, it is unbalanced. And what's going to happen? Well, because net force is downwards, he's going to accelerate downwards. All right, taking a look at number 2. Number 2 is very similar. So what force pulls him down? Let's see, what force is pulling him downwards? What force pulls you down? What keeps you in your chair? Force of gravity. So force of gravity, okay? And the next question is, what force is pushing up on them? Well, I'll give you all this one. It's the buoyant force, the force of buoyancy, okay? Little b. All right, because these are going in opposite directions, I have 80 newtons down and 70 newtons up. Because they're going in opposite directions, again, I'm going to subtract, and I get a net force of 10 newtons going down. So in other words, what's going to happen to him? He's going to move down, or you could say he's going to sink. All right? Again, this is called our net force. It's our answer. All right, so our net force is 10 newtons down, and he is going to sink. Next one. You don't need to draw this. This is an inclined plane. And the way an inclined plane works is it increases the distance you have to move an object. And by doing that, it decreases the force. So for example, right here, they can pick this up 1 meter high. Let's say this is a force of 100 newtons. Okay, well, what would be easier is instead of picking it straight up 1 meter, what if they slid it up a ramp? That's 4 meters long. So 4 meters. And what that does is it makes it 4 times easier. So instead of having to push with 100 newtons, they only have to push with 25 newtons. So the way an inclined plane works is it reduces the force needed by increasing the distance. You move it 4 times as far, however, it is 4 times easier. So go ahead and draw this one and label it an inclined plane. So the question is, and this is a test question on the benchmark, guarantee you'll see it, is which one of these would require the least amount of force? Okay, so here I have a ball that's going to move a long distance. And here I have a ball that's going to move a short distance. Okay, you can see that this one's going to move a lot further. If these balls have the same mass, this ball, the first one, is going to require the least amount of force. And why? Because it has a greater distance to move. So it's a trade-off. You have to move further. However, you move further using less force. Okay, and that looks very similar to a question on the test. The top one would require less force. Why? Because you have to go a greater distance. Okay. Moving on. Then we have some word problems. Whenever you work a word problem, it says you always want to write your formula first and then fill in your formula's numbers and solve. All right, so it says, it took Lily 7 seconds to ride her bike 35 meters to the end of the block. What was her speed? Show your work. All right, so first thing I do is I write my formula. Speed is equal to distance divided by time. I plug in my numbers, 35 divided by 7. And then I solve. And the way I solve is I don't want to see y'all doing long division. I want you to use a calculator. So if you get your calculator and say 35 divided by 7, you'll find out that it is 5 meters per second. Okay, moving on. Next example. What is the speed of a cheetah that runs 112 meters in 4 seconds? Show your work. So speed is equal to distance divided by time. Which, by the way, I guess I passed it up last time. This fraction bar right here means to divide. So this bar right here means to divide. If you don't realize it, everybody's familiar with the fraction 1/4, right? You know what 1 divided by 4 is? 0.25. What is 0.25? It is a quarter. Okay, a quarter, in other words, 1/4, or 25 cents, which is 1/4 of a dollar. Point being, that bar right there means to divide. So, distance divided by time is equal to, my distance is 112 meters. My time is 4 seconds. What is 112 divided by 4? It is 28. Very good. And I don't want to see you trying to figure out on paper. I want you to plug it into a calculator. 28 what? 28 meters per second. All right. Moving on to the next one. Rolling on. Number 7, a bullet travels 5,000 meters in 4 seconds. What is the speed of the bullet? Show your work. Oh, we don't need to do this one. We already did 2 examples. All right, next one. Here's Bart Simpson. Everybody draw a house. Bart Simpson leaves his house. Draw the arrow. And he goes to school to do his detention. So he goes to school. And somehow the number ended up right down here. That's 50 meters. Okay, so he went 50 meters from his house to school. And then after he did detention, he went and got a donut. And that was 30 meters to get a donut. First question, what is his total distance traveled? 80 meters. Very good. He traveled a total of 80 meters. Next question, what is his displacement? In other words, how far is he from where he started? 20 meters. Okay, so what they're asking is how far is he from where he started? So if he had to get from the donut shop back to home, how far does he have to go? What is his displacement? Okay, and that would be 50 minus 30 is 20 meters. That's how far. So distance is the total distance covered, whereas displacement is how far are you from where you started. Okay, easy enough. Okay, next one. Bart goes from his house to his dad's work. From work, they go get a hamburger, and then they go back home. What was his total distance? He went 50 meters, he went 20 meters, he went 30 meters. Very good. 50 plus 20 plus 30 is 100 meters. That is his total distance. Next question, what was his speed? Well, speed is equal to distance divided by time is equal to, what was the distance that he traveled? He traveled 100 meters. How long did that take him? Well, 15, let me use a different color. 15 plus 5 plus 5 is 25. 25 seconds. 100 divided by 25 is 4. 4 what? Meters per second. That comes from right here, meters per second. Okay, easy? Yes, hopefully. There's one like this on your benchmark. I'll tell you it's a lot harder than this because instead of having 3 measurements, they have like 6, and they're using decimals. So instead of saying like 50 meters, they say, oh, 53.72. And anyways, don't get confused, just use a calculator. There's no reason to sit there and do long addition and division. Yes, you can use calculators. I prefer to use calculators. I always tell kids, I'm teaching you science. I'm not teaching you how to do long division. All right, so I believe that's it. That's it. I believe this one right here is on your on your Schoology. So what you're going to do is, when available, you'll do the activity in Schoology. Basically, out of those 3 types of problems we just did, it has 1 or 2 for each type. And go ahead and get started if you can. If not, just try to do it for homework. That's it. Schoology is down.